Okay, yeah. Let's pray. Thank you, God, for this beautiful morning. Thank you for guiding us in our sleep last night. Now we gather here in Zoom meeting. We want to discuss the last year's mid test. Please bless all of us so we can discuss it well. And later on, the students can do their mid test really well. In the name of Jesus, we pray. Amen. Okay. Don't forget to open your camera. Yeah. Okay. So I'm going to start sharing my screen. So this is basically the file of our mid test. Yeah, take a look at this one. Number one, Andre, Bobby, and Chandra are traveling from Jakarta to Yogyakarta by using Senja Utama Jogja train. The train departs from Pasar Senen Station at 19:00 Western time, yeah, and arrives in Yogyakarta at 4:00. Andre and Bobby sit side by side in business coach number 3, while Chandra is sitting in business coach number 4, which is basically behind Andre and Bobby. Yeah? After the train leaves, the conductor checks the seats of the passengers. The correct statement about motion based on the above story is so the thing about motion, we know the terms of the relative motion. Yeah. So it seems like the object is moving, but basically not. We are moving. When you're driving a car and then you see a person in the sidewalk, it seems like the person is moving towards us. Okay. In fact, the person is standing still, but we are the one that is moving. Okay. So in this case, we cannot answer B. Andre moves toward Bobby. Why? Because they are sitting side by side, right? Okay. So they move along together. Okay. And C, business coach number 3 moves toward business coach number 4. Okay. This one is wrong because the seat in the train is attached. So the distance stays the same. If the train is moving, the seats are moving also along with the train. Okay, so the distance between those two is still the same. Okay, D, Chandra moves towards business coach number 4. This one is wrong because Chandra is sitting in business coach number 4. Okay, so the answer for this is the train moves toward. In this case, bukan menuju ya. In bahasa we call it the menuju. The train moves toward Pasar Senen Station. In bahasa means kereta bergerak terhadap Pasar Senen Station. Okay, because the train departs from Pasar Senen Station. So the answer for this is A. Okay. Do you have any questions for number one? Nope. Okay. We know that the answer key for all the questions are A, yeah? But we have to understand the reason why A is the answer. Okay, number two, in a scouting activity, the shipyard 4 walks from the school gate to the north about 100 meters till he reaches the Bank DKI. Then he turns 80 meters to east towards the old buildings and turns 40 meters to south and stop at a field. The distance and the magnitude of displacement of the strip are. So for this case, it's easier for us to draw the path. Okay, so I want to note it first. The first one, this one is basically polygon method. Walks from the school to the gate to the north for 100 meters. This one is north. And then he turns 80 meters to east. This one east. Okay, and then 40 meters to south, ya ke bawah. Okay, and then we need to label the distance reached by this person. Yeah, the first one is 100 meters north. And then we have 80 meters to the east and then 40 meters south. Okay, this one is the starting point. This one is the final point. Okay, so we know that the distance equals to 100 meters plus 80 meters plus 40 meters. What's the answer? 220 meters, yeah? So the displacement, this one is pretty easy because when you take a look at this carefully from start to finish, and then there's a helping line in here. This one is our displacement, right? Okay, this one is our displacement. Okay, how can we find the value of this displacement? By using, see what? Pythagorean theorem, yeah? Got it? Okay, so we need to find out the length of this. This one is 80 meters. And then what's the length of this?
60.
It's 60. So we can find the value of our displacement. The displacement is basically the square root of 80 meters squared plus 60 meters squared. Yeah, so the displacement equals to the square root of 6400 meters squared plus 3600 meters squared. So the displacement is the square root of 10,000 meters squared. Okay. It's 100 meters. That's the displacement. Okay. Any questions? No questions? So far, so good. Don't forget to write it down, or you might want to take a snapshot, yeah, for this process. Okay. No questions? Okay. Shall we continue to the next number? Okay, yeah. Number 3, a child walks around a circular field as shown. If the child walks 2.5 times in, it means like 2.5 laps, yeah, in 100 seconds. So the magnitude of the velocity and the speed of the child. Okay, so this one is pretty easy. Let's say this one is the starting point, right? This one is the starting point. Okay, and then this one, because it's 2.5 laps, so the walk will end in here, right? See, that is 1 lap, 2 laps, 2.5 laps. Okay, so the walk will end up across the starting point. Yeah? This one is the start, and this one is the finish. Okay, in order to find the velocity and the speed, we have to find out the distance and displacement. Okay, because the distance is basically 2.5 times the circumference of the track field. Okay, it's 2 times pi times r, yeah. So the distance equals to 2.5, 2 times 22/7, because the r is basically the factor of 7. It's 14 meters. Okay, sorry about the wrong notation in the diagram. It should be 14 meters and not centimeters. Got it? So we can cancel this one. 288 times 2.5. How much is that?
88.
88 times 2.5. Because 2.5 laps, right? $220. It's 220, yeah. So that is the distance covered. And then we need to find out the displacement. What do you think about the displacement? Anybody?
28.
It's 28 because it's right across the track field. So it's got to be the diameter of the track field, right? Okay. To make it clear, I want to draw the straight line. So that is basically your diameter. Using arrow, I think it's better. There you go. Okay, it's 28. That's correct. It's 28 meters. Okay, what about the time? The time is like 100 seconds. So we can find the speed equals to distance over time. So the speed equals to 220 meters over 100 seconds. It's 2.2 meters per second. Even though we can actually choose the answer right away ya. Karena yang ditanyakan velocity first and then speed. Ya. So make no mistake about it. Ya, yang ditanya magnitude of velocity and speed sequentially, not speed and velocity. Okay. And then the velocity equals to displacement over time. So it is 28 meters to the right. Okay. So the answer is A, because velocity is asked first and then the speed. Yeah. Got it? Any questions? Any questions, guys? No questions? Okay. Don't forget to take snapshot. Yeah. Number 4. Look at the graph of velocity and time below. The average velocity of that object is how to find the average velocity. The average velocity, yeah, is basically the total distance, the total displacement divided by total time. Okay. So we need to find the total distance first, not adding this velocity and then divided by 3. That is wrong. Okay, so in order to find the total distance, this one is the speed in the first part of the graph times the time, yeah, of the first part of the graph, and then the speed in the second part of the graph times the time of the second part, plus the third speed of the third part of the graph, yeah. Okay, divided by total time. The total time is 40 seconds, yeah. Okay, so this one is a little bit tricky because the speed of the first part of the graph is 4, yeah. Here, this one is 4. So it's 4 meters per second times the time. How much is the time? 15 seconds, yeah. So we change this with 15 seconds straight up, plus v2 is 10. This one is 10 meters per second. And then the time is not 35. It is from 15 to 35. How much?
20.
20. Yeah. Make no mistake about it. Okay. Because most of the students made mistake in this part. Yeah. In putting the time into this formula. And then the third speed or velocity is 6 meters per second, or from 35 to 40, 5 seconds. Yeah. For 5 seconds only, times 5 seconds divided by 40 seconds. Okay, so the average velocity is 4 times 15 is 60 meters, plus 200 meters, plus 30 meters, divided by 40 seconds. So it is 290 meters over 40 seconds. Yeah. So the answer is 7.25 meters per second. That is the average velocity. Okay. The answer is A again. Any questions? Everyone, do you have any questions? No? Okay, next up. The graph that shows the relation between distance and time in uniformly motion in a straight line. Okay, so we need to know that UMSL is two constant speed, yeah, constant speed. The speed is not changing. Okay, this one is distance versus time. So this is the answer, yeah, A. Okay, because in uniformly motion in a straight line for every second, the increasing distance is constant. Yeah, so if it's like 2 meters per second, it means like in 1 second, the distance traveled is 2 meters. After 2 seconds, the distance traveled is 4 meters. After 3 seconds, the distance traveled is 6 meters. So the increasing distance is constant, right? 2 meters, 2 meters, 2 meters. Okay, so that's why the answer is this, A. What about B? B is the graph of what? B is the graph of what? Throughout the time, the distance is not increasing. Artinya apa? What's the meaning of this?
Not moving.
Not moving or at rest, yeah? What about this? This one is UA MSL or accelerated motion. For every second, the increasing distance to not constant, yeah, becomes bigger. Yeah, this one is suitable for the graph of velocity here. Why? Because when you take this one as a displacement, it means that it has a direction. Yeah, it can go to the left, downward, to the right, upward. Yeah, if the distance is decreasing like this, it means like the object is moving towards a negative direction, to the left or downward. Okay, any questions? No questions? Okay, next up, anybody who wants to answer number 6? A flag raiser walks in constant velocity 2 meters per second to the flagpole. Initial position of him was 30 meters from the flagpole. The position of the flag raiser after he walked for about 6 seconds from initial position is, anybody can answer this one? So this one is the flag. Okay. And this one is the flag raiser. The distance initially was 30 meters. And then he walked with the speed of 2 meters per second for about 6 seconds. Yeah. So the distance covered by this flag raiser is 2 meters per second times 6 seconds, which is
Oh,
12 meters. Now he becomes closer 12 meters to the flagpole. So after 6 seconds, his distance to the flagpole is 30 meters minus 12, yeah? Okay, hasilnya berapa? 18 meters from flagpole. Okay. Any questions? No. Okay. Next up, number 7. Car B is behind 30 meters of car A in a straight line. If the velocity of car A is 8 meters per second, and the velocity of car B is 12 meters per second, so car B will catch up car A at, I mean, how long, or not how long, yeah, at what distance, yeah, car B will level up with car A. So the first thing we need to find out is the time for car B, uh, is the time of car B to level car A. Yeah? So the time equals to the distance between them, the gap is the gap between them divided by the speed of B minus the speed of A. So the time needed to catch up car A is 300 meters over car B is like 12 meters per second minus 8 meters per second. Okay, so the time needed is 75 seconds. So it'll take 75 seconds for car B to level with car A. Okay, so now we want to find out the distance. Yeah, I want to draw this one so you can understand. So this one is car B, that direction, and then we have car A. Okay, the distance between them initially was 300 meters, right? And then B, okay, they will level with each other. So at this point, the level will be like this, right? So both car are level to each other. A and B level. Okay, the question is, at what distance they both will level up? Okay, so let's see. B is moving 75 seconds. A is moving 75 seconds also. Okay, so it's up to you. You want to take in a B as the initial reference point or A. Yeah. So the distance from B, if it's B, the distance they will level up is the speed of B times the time they will catch up. Okay. So it is what's the speed? 12 meters per second times 75 seconds, which is 900 meters. Yeah, if you want to calculate it from A, so it is the distance covered by A, speed of A times the time to level up. Yeah. So the distance of A equals to what's the velocity of A? It's 8 meters per second times 75 seconds. How much is that? 600 meters. Okay. So the answer is A. Yeah. You know that, sure. Okay. And then the picture is correct. Yeah. It is 600 meters from A initial point, or the total is 300 plus 600 meters from initial point of B, 900. Yeah. Okay. Any questions? No questions. Okay. Next up, number 8. When will they meet? I don't know, because the question is not. I think it should be like this. Yeah. So the distance between them is like 1,200 meters. Okay. In order to find the time to meet each other, it's pretty easy. Yeah. I already told you about this. VA plus VB. Yeah, the origin of this formula is in your PowerPoint presentation. Eh? Okay, so D equals to 1,200 meters. divided by the speed of A is 6 plus the speed of V is 4. Yeah. So the time is 1,200 meters divided by 10 meters per second. Okay. So time is 120 seconds, which is equal to 2 minutes. Yeah. Any questions? For number 8?
No.
No? Okay, next up, the meeting is recorded. So later, you can see the recording of this video. Kalau sir bisa downloadnya ya, tapi belum pasti. Okay. Number 9. Look at the following statements. Based on the statements above, uniformly accelerated motion in straight line with deceleration. Deceleration means the changing of speed is negative, yeah, or decreasing speed. Okay, this one is deceleration. So which statements that indicate a deceleration? Let's have a look. Which one?
One.
One. Okay. What else?
6.
6. Okay. 1 and 6. I guess, yeah. What about number 5? Marbles rolled on the flat, smooth floor. It's basically a deceleration also. Yeah. It doesn't matter if the floor is smooth or rough. Yeah. Eventually, at some point, it will stop. Yeah, it will be different if the statement goes like this. Marbles roll on the frictionless surface. Okay, so that is wrong. But in this case, we don't have the option of 1 and 5. Yeah. Neither 5 and 6 or yeah, or 5 and 6 here. So A is the only answer, I guess. Okay. Number 10. The order of the acceleration of the object's motion from smallest to the largest. Yeah, so we're using the first kinematics formula for this one. Okay. Acceleration equals to the final speed minus initial speed over time. Okay, let's see object 1. Object 1, the acceleration equals to 20 meters per second minus initial speed is 10 meters per second divided by 5 seconds. So what's the answer? 2, yeah. And then you take a look at object 2. The acceleration is 12 meters per second. That's the final velocity minus 0 divided by 8. Sorry, 8 seconds. So it's gotta be 1.5 here. Then you take a look at the object number 3. The acceleration equals to 25 meters per second minus 5 meters per second over 20. So it is 1 meters per second squared. So the order of the acceleration from smallest to largest, yeah, berarti 3, 2, 1. Okay. That's it. Any questions? No questions? Okay. 11, look at the graph of velocity and time below. So this one is different with the previous number. Yeah, this one is velocity versus time. Based on the graph above, the one shows uniformly accelerated motion in a straight line. For positive acceleration, it's gotta be A, yeah. Okay, this one is pretty obvious. What about B? B is
B
UMS.
at rest.
Yeah, UMS at a constant speed. This one is deceleration. acceleration. Oh, A is negative, negative acceleration. UMSL, the acceleration is 0. This one is non-uniform acceleration. So the acceleration is changing throughout time. And we're not learning about this. Okay, non-uniform acceleration. Okay, so it's pretty obvious. Number 12, a plane takes off in a speed of 80 meters per second. If the acceleration of plane is 2 meters per second, so the minimum distance of runway in the airport is, okay, so we have takes off. This one is the final speed. We know during the takeoff, the initial speed of the plane is 0. And then the acceleration given is 2 meters per second squared. So we need to calculate the minimum distance of the runway. Okay, this one is the runway. And this one is the aeroplane. Okay, the initial speed has to be 0. And then the train moves, accelerated until it reaches the takeoff speed. Yeah, what would it take off? Got it? So in this case, the takeoff speed here has to be 80 meters per second. Okay, so the question is pretty easy. Yeah, what is the minimum distance of the runway? Okay, we have to use the third kinematics formula because we are independent with the variable of time. Okay, so we need to use this formula, Pf squared equals to Po squared, so Pi squared, sorry, plus 2 times acceleration times the distance of the runway. Yeah, this one is the third kinematics formula. Okay, and now we just need to plug in the numbers here. So 80 meters squared, meters per second squared. I mean, 0 plus 2 times 2 meters per second squared times the distance. Okay, so far, do you have any questions? Pi squared, because Pi is 0. If it's squared, it's 0 also. So 80 meters per second squared is 6,400 meters squared per second squared equals to 4 meters per second squared times d. Okay, and then we move on to this. So d now equals to 6,400 meters squared per second squared divided by 4 meters per second squared. Okay, second squared cancel out each other, meters and meters squared. So the unit left is only meters. Yeah. So it is 1,600 meters. Okay. Any questions? Remember, yeah, during the takeoff, the initial speed has to be 0. Okay. Must be. Any questions? Halfway through. Okay. Number 13. Look at the graph of velocity versus time below. The average velocity of object from A to E is, what is the average velocity from of object from A to E? Anybody can answer this one? Anybody can answer? I don't think the options are correct yet. Because it has to be in English, yeah. So this one is 6,500. So instead of using comma, I think we need to use dot there. Yeah, or else people will understand this one as 6,500. Okay, got it? Okay, now we have the changing speed, yeah. So because we have the changing speed, I think it's easier for us to, the average velocity, total distance, yeah, divided by the total time. So how to find the total distance? It's pretty easy. If the graph is t versus t, the area below the graph is the total distance. We just need to calculate the area below the graph. So to make it easier, I think we can divide this area into three. The first one is one, this one is the second, this one is the third. Okay, so the average velocity, the total time we know it's 20 seconds, yeah. Let's calculate the area, the first area. How much? The base is like 2, okay, and the height is 10. Half of base times height, yeah. This one is a triangle, right? So it is,
10.
yeah, 2 times 10 divided by 2. So the first one is 10 meters. Okay, if you want to write down the units also, I think that is okay, no problem. Yeah, let's try to do it. The base is 2, yeah, 2 seconds. Okay, and then the height is the speed, yeah, meters per second, 10 meters per second. Okay, the second cancel out each other, 2 cancel out each other, so the answer is 10. Okay, and then the area of the second part, the graph here, from 6 to 16. So the base is like 10 seconds times the height, because this one is a rectangular, yeah. So we don't need to divide it by 2. Yeah, width times length atau times height. The height is 10 also, yeah. Okay, so the area equals to 100 meters. Okay, and then the third one, it's a triangle again, from 16 to 20, that's 4, times the height is 10 also, meters per second, over 2. Yes, 20. Okay, so the total is like 130, yeah, because it is 10 meters plus 100 meters plus 20 meters. Okay, so now the average speed equals to 130 meters over 20 seconds. So that's why the answer is 6.5, yeah. Okay, so you can see this one should be 6.5. Any questions? No questions? All good?
No, sir.
Okay. 14. A ball is dropped from a building of 45 meters high. The speed of the ball when strikes the ground is how much? Okay. Yeah, this one is the fastest way to find the speed when it hits the ground. Okay. This one is the fastest. How can we get this one? It is from the third kinematic formula, yeah? Because we're using Vf squared equals to Vi squared plus 2 times G times H. Because now we have the vertical motion, yeah? The distance changed into height, the acceleration changed into gravitational acceleration. Okay, got it? Okay, and when the ball is dropped, it means that the initial speed has to be 0. Okay, jadinya Vf squared equals to 0 plus 2 times G times H. Jadinya Vf equals to the square root of 2GH. Okay, Itu cara cepatnya. Jadi V equals to the square root of 2 times 10 meters per second squared times 45 meters. So the speed when it hits the ground is the square root of 900 meters squared per second squared. It's 30. Here you go. Any questions?
No, sir.
So yeah. Okay. Next up. 15. A bullet was shot from a rival straight up with a velocity of 50 meters per second. If the acceleration of gravity is 10 meters per second squared, then its maximum height was. So it's vertically upward motion, yeah. Okay, so let's say this one is the bullet. The bullet will go up until it reaches its maximum height, yeah. The initial speed is 50 meters per second. And the gravitational pull is like -10. Why -10? Because the direction is in the opposite of the object's motion. Okay, so the G is decelerating the motion. Okay, decelerating the object. Okay, and then the question is, what is the maximum height? At maximum height, the final speed has to be 0. Yeah, that's the requirement. Okay, so we're using the third kinematics formula because we are independent with the variable of time again. So Vf squared equals to Vi squared plus 2 times G times H. Okay, so this one is 0. Vi squared is 50 meters per second squared plus 2 times 10 meters per second minus, yeah, minus 10, sorry, times H. Okay, so now 0 equals to 2500 meters squared per second squared minus 20 meters per second squared times H. Okay, so 20 meters per second squared times 8 times H equals to 2500 meters squared per second squared. Okay, so now the height is 2500 meters squared per second squared divided by 20 meters per second squared. Second squared cancel each other, meters. Sisanya tinggal meters ya. So it is 125 meters. Okay. That's why the answer is A. Anything else you want to ask? So far? No? All good, yeah? Next up. Notice the following type of forces. Notice the following type of forces. The non-contact forces are 1, of course. What else?
2.
Number 2, the gravity. Last but not least,
6.
yeah, electrostatic, yeah. Okay, 1, 2, and 6. What is electrostatic? Is the force acting on two charges, yeah. Take an example. When you rub plastic foam, scissor plastic with your hair, eventually it can attract small pieces of paper, right? So that is basically the electrostatic force, almost the same like magnetic. Okay. Number 17, look at the following figure. The resultant of forces Fa plus Fb plus Fc. So we're going to use polygon method ya. Langsung aja Fa, Fb, Fc ya. A. Okay, it's A. Yeah. FA plus FB plus FC. This one, eh? Okay, next up, number 18. Three stones at different planets are measured and recorded as shown in the following table. P, Q, and R. Okay, the mass of P is 2 kilograms. The mass of Q is 1.5, and then the mass of R is 3. Okay, and then the gravitational acceleration in the different planets are presented in the table there. The order of weight of the stones from smallest to the largest. We know that the weight is the mass times the gravity, gravitational acceleration, yeah? So for this one, the weight is 10 newtons, 2 multiplied by 5. This one is 1.5 times 8, it is 12 newtons. And this one is 18. Okay, 10, 12, and 18 newtons. From smallest to the largest, berarti ya P, Q, and R. Okay. Next up, number 19, look at the following statements. The factors that influence the magnitude of friction. Apa?
Surface roughness.
Yeah, the friction is basically the coefficient of friction times the normal force. Yeah, if you want to make it more specific, the normal force is mass times the gravity. Usually, yeah, in the flat surface. Okay, so this one represents the surface condition. Smoothness, yeah. And now we have also the variable of mass of the object. Okay, so it is surface roughness and a normal force. Okay, it doesn't have anything to do with the color of the object, yeah, or even the area of the surface. Okay, sometimes students got tricked about that. Apakah luas dari bagian bawah objek berpengaruh sama friction force? No. Okay. So the answer is 1 and 2. Next up. Number 20, look at the following statements. The phenomena that applies at Newton's first law. Yeah, it's the law of inertia, yeah. Which one? A marble rolls on a smooth plane floor at constant velocity. Constant velocity, yeah. Remember, the condition of the Newton's first law is the balance force, yeah. An object at rest will stay at rest. An object that is moving will keep moving with constant speed. Yeah, so we have two conditions: resting object and moving object with constant speed or velocity. Okay, a passenger is thrown forward, not when the car is suddenly braked. Yeah, this one is the example of inertia in our daily life. So the answer is 1 and 3. 21. All blocks are identical, exerted by a force of 300 newtons and accelerated to 2 meters per second squared. If two blocks are removed by the same force, they can be accelerated. So this one is pretty easy. This one is a comparison. Okay, comparison. Okay, so F1 equals to F3, F2, yeah. Okay, because we're using the same force, yeah. This one is the first mass times the first acceleration equals the second mass times the second acceleration. The first mass is how much? 1, 2, 3, 4, 5, 6. 6m times 2 meters per second. This one is the first acceleration here. Okay, and then the second mass, 2 blocks are removed. Berarti dia tinggal 4m times a2. Yeah, m cancel each other. Okay, so 6 times 2 is 12 meters per second square equals to 4a2. A2 equals to 12 meters per second square divided by 4. It's 3. Yeah, this one is the key. The force by the same force. Okay. Any questions for this one? Nope. Number 22. If the object's mass are the same and exerted forces and exerted by the forces as shown in the figure, then the object with the largest acceleration. Okay, we just need to find the ratio of because mass are the same, yeah. So the acceleration is proportional to the total force acting on the object. Okay, the first one, what's the total force acting on the object?
20.
20. What about this one?
0.
0. This one?
-5.
-5. Well, 5 newtons to the left. What about this?
10.
No. Is it 10?
10.
This one?
30.
30 newtons. Yeah. So the bigger force has to be the biggest force has to be the biggest acceleration, yeah. Because the mass of the objects are the same. Okay. So we just need to look at the sigma. All right. Next up, number 23. If F2 equals to 15 newtons, the friction is 10 and the object is accelerated at 2 meters per second square to the right, the magnitude of F1 is, we know that the object is moving to the right. So it means that the friction force has to be to the left. Got it? Okay. Now we want to find F1. The sigma F equals to mass times acceleration. Okay, the total force acting on object is 3. F1 to the right, positive, minus F2 to the left, minus the friction force, equals to 5 kilograms times mass times A. So F1 minus F2 is 15 newtons from the question here. The friction force, 10 newtons, equals to 5 kilograms times 2 meters per second squared. So F1 minus 25 newtons equals to 10 newtons. Therefore, F2 equals to 10 newtons plus 15. F plus 25, sorry.
Sir, ito
Equals
F1
to-
dong.
Oh yeah, F1, sorry. I'm mistake. Okay, F1 equals to 35 newtons, yeah. The key is this. The object is moving to the right, accelerated to the right. It means that the friction force has to oppose the motion to the left. Any questions?
No, sir.
Two more numbers, yeah. After this, you need to fill the attendance list ya. Jangan langsung pergi ya. Number 24, look at the following statements. The phenomena that applies the Newton's third law. Yeah. Number 1, a cupboard pulled by 2 kids is faster than 1 kid. I don't think this one is Newton's third law, action reaction. This one is Newton's second law. Number 2, when a hammer strikes a nail strikes back to the hammer. Better, yeah. And then a paddle pushes water backward. The water pushes the paddle forward. A tablecloth is pulled quickly. Water in the glass on it does not spill. That is the inertia.
Inertia.
Number 25. Look at the following figure. The object's mass is 10 kilograms. The coefficient of static friction is 0.4. And the coefficient of static friction I don't get it. It has to be kinetic. I guess so. This one is the kinetic friction is 0.2. And the pulling force is 30 newtons. The object's acceleration is, so we need to determine whether the object is moving or not, right? So we need to find the Fs max. Okay, static friction, maximum static friction force. So it's mu s times n. It is mu s is this one, yeah, 0.4 times the mass is 10 kilograms. We know that the gravity is 10. Yeah. It is 40 newtons. So what is the object's acceleration? Yeah, because the F is smaller than the Fs max. It means like the object is not moving. Okay, pulling force only 30 newtons. And then the maximum static friction here is 40 newtons. Yeah. So I think that's it. If you don't have any questions, you have any questions for this one?